This question is for Darren Morgan of Boeing and Lyndon of Etihad Airways. In an ideal world, in 10, 15, 20 years, what percentage of your fuel would be coming from this biofuel?
I think it is still early days in terms of trying to make those predictions. I think one of the important points to note is that one of the reasons that aviation has maybe been a bit slower into this game than maybe other uses for bioenergy is that we always said that it had to be something that was fully mixable with regular jet fuel. So to be honest, whilst we want to aim for very high levels in the future, even if there are small amounts, it's fully mixable with the fuel that we use. So we're not really looking at setting ourselves targets that far in the future right now. We're just looking to push and game change and make sure that we can maximise that opportunity. And we can take the small amounts, we can take the big amounts, we can mix it fully with regular jet fuel and hope that it comes online.
As much as possible, as soon as possible, subject to the constraints of sustainability. And it a little bit alluded to in Lyndon just said, if you don't get to 1%, you don't get to 10, 15, 20, 80. So our key focus here is to get to 1%, metaphorically and literally, because without that you can't take the next step. And by focusing on this and doing the experimentation and development process in a small, controlled way, we avoid the risking of a large project right out of the gate, and we can manage this in a way that is not going to have the same outcomes as a lot of other biofuel projects, which went very big very quickly, only to find out they didn't do some homework on the science. So we're going to be very small about this in size, but very big in concept.
Yeah, I know it's annoying to get asked for specific targets way out into the future. It's not about targets. I'm just, if everything went really well, could this become a majority, you think, in 50 years? I mean, just as a dream, as a hope, not as like some official statement of a target or a goal.
Well, if you look at the goals for aviation, the carbon reduction goals that were alluded to earlier, you have to change the fuel to get there. I can tell you, we're doing as much as we can on better airplanes. They're doing as much as they can on flying them and flying them. And that's not enough to get to carbon neutral growth just by itself, even though we'd like to say we can do that all on our own. The reality is you do have to change the fuel to get to that target. So there's sort of a forcing function. The industry is committed to carbon neutral growth. You have to change the fuel, and we're trying to drive the technology to cause those things to happen and bring the right players along, like the people here in the UAE that are doing all of these great and innovative things. I mean, these synergistic, innovative partnerships.
Estimate. The idea is for us to be, to be very aggressive and try to answer the questions, push the system so that we can answer the questions as quickly as we can. The idea and the philosophy behind this is that this is a way of learning fast. So the ultimate goal is for us to be able to move to a larger facility that in principle will have 200 hectares. So we're growing this facility by 100 times. And at that scale, we would have about 140 hectares of Salicornia planted. About the remaining 60 hectares will be divided between the mangrove section and the aquaculture section. And at that level, we start creating enough scale to start producing fuel for, I guess, more intensive use. Now, we have to bear in mind that a commercial farm is considered to be a farm of 20,000 hectares. Okay? So the 200 hectare level is actually going to help us just have the proof of concept that this can be scaled to a much larger size. So the idea is to move from there to a commercial level. And so the pilot will be operating, initially for 3, maybe 5, but potentially we could keep it open because the idea behind this is to start, bringing in new species of halophytes, understanding perhaps some ideas behind intercropping some of the species, at first, we're using a methodology for planting it's an annual plant. So we're going to be planting it, in this region at the beginning of October, and we're going to be harvesting at the end of May. And then we'll use the biomass that is generated from that. But there's also the possibility of cultivating a perennial grass or a perennial halophyte that will allow us to trim it and take the trimmings as our source of biomass. So there are many things that can be done. And so, again, initially from 3 to 5 years, and potentially for a long time. In terms of the quantities, the plant, as we know it today, is basically a wild plant. One of the research projects we conducted over the last 2 years, 3 years actually, is actually a characterization of the germplasm of the specific plant that we are interested in. And so this was a very ambitious collection effort around the world, collecting the seeds of Salicornia bigeloviae so that we could have a library of the different types of Salicornia bigeloviae that are out there. And so now we have that library, and the plant as we know it today, the results that we've obtained is that we can get about 2 tons of seed per hectare, and from that, there's about a 30% oil content. Now, we have to remember that if we have a hectare that is planted with Salicornia, we will get 2 tons of oil seed, but we will also get 18 tons of biomass. Okay? So this project is going to be using the oil seeds for one pathway, and then the biomass, the plant itself, the bush itself, for another pathway. And so in total, you have a much larger pool to pull from. And it's not far-fetched to think that this is the plant as we know it today, basically in its wild state. With very simple agronomic techniques, we believe that we can get the plant to at least double its yield in a very short time frame. And I can only give you examples that are out there in the commercial world. Corn in the 1960s was giving about 3 tons per hectare. It now gives more than 20. So again, and this is not GMO, nothing that has to do with genetic modifications. It simply concentrates on agronomic engineering. And I cannot quote any specific numbers of that specific study, but I can tell you that the overall result is that we have a net carbon benefit. Because of how the system is designed, we can see that there is while the plants are growing, there's an absorption of CO2, and while the mangroves are growing, there's also a significant absorption of CO2. And so when we consider the full life cycle, when a fuel is produced using these plants, the CO2 that is absorbed during the growth of the plants is the one that you're burning when you use the fuel. And so through the life cycle, compared to fossil fuels, there's a study that has been done by a project at MIT, the partner project, that has looked at different feedstocks and evaluated their life cycle ability to reduce carbon emissions. And so you have, depending, as Barbara pointed out, you can have a biofuel that is done very wrong and you'll have terrible consequences. But if you do it right, Salicornia has the potential to do perhaps a saving of about 80% compared to a fossil fuel. Definitely, we need to monitor whatever comes into the system, and we need to make sure that the water is in a condition that allows for the viability of the system. This is actually a very big challenge for us in this region of the world, because the water here is actually saltier than what I would say average seawater. So the water in the Arabian Gulf is actually about 44 parts per thousand. Traditional seawater is anywhere between 33 and 35. So this in and of itself is actually presenting a big challenge, because some of the species, some of the aquaculture species that most people are growing are not able to grow in this type of water. The temperature of the water here is actually much higher in the summer months than in other places around the world. It's a terrestrial plant, it's not an aquatic plant. So this is why we're concentrating on the halophyte species. Excellent question, because that's exactly one of the questions that we're trying to answer through this. So the reason why we designed the facility in this way is because we can start playing around with those numbers, the intensity level and the nutrient level that will be generated in an intensive pond versus a medium intensity versus a low intensity is different. The fertilizer requirements for the plants will be different depending on the nutrient level that is present in the water. And so we're not actually canceling the option of using fertilizer during the process of growth of the Salicornia plants. It's just that we don't know yet. We have some numbers that we have used to grow plants in the soil over the last 2 to 3 years. So it's an indicative measure, but I don't have the numbers to tell you right now.
Is that one of your goals, to try to be self-sufficient?
Exactly. So the ideal would be that we don't need any fertilizer. That would be the best case scenario. And if we do need some fertilizer, we need to make sure that it doesn't trickle down into the ocean, because that